This video introduces prime numbers and relatively prime numbers. An integer greater than 1 is called prime if it has only two positive factors, 1 and itself. For example, 13 is prime. Its only factors are 1 and 13, but 15 is not, since it has factors of 3 and 5 in addition to 1 and 15. An integer greater than 1 is called composite if it is not prime. In other words, it does have positive factors besides 1 in itself. So 15 is a composite number. Note that 1 itself is neither prime nor composite. One way to decide if a relatively small number is prime is using trial and error, or trial division. I'm going to start dividing it by numbers and see if it works. Well, 2 definitely doesn't divide 127. 3 doesn't divide 127. I'd have a remainder of 1. The next number is 4, but I don't actually have to check if 4 divides 127, because if 4 divided it, 2 would also divide it, since 2 is a factor of 4. So I can skip 4, go on to 5, skip 6, because I've already tested its factors, 2 and 3. If 6 divided 127, its prime factors would have to divide also. So I really only need to check prime numbers and see if they divide 127. 7 doesn't divide 127. 11 doesn't divide 127. And really, I don't need to keep going any further than this. I don't need to check 13 or any bigger prime numbers, because if 13 divided 127, then some factor smaller than 13 would also have to divide. Since 13 times 13 is 169, which is greater than 127, 13 times x equals 127 would have to mean that x was less than 13. So in conclusion, I only need to check prime factors less than or equal to the square root of the number that I'm trying to decide if it's prime or not. In this case, I've tried all the prime numbers less than or equal to the square root of 127. None of them divide it, and therefore 127 is prime. The sieve of Eratosthenes is another method for finding small prime numbers all in a batch. How it works is I cross off the numbers that are not prime in an organized way. First, I cross off 1. It's neither prime nor composite. 2 is prime, but I'm going to cross off all multiples of 2 greater than 2 itself. The next number, 3, is prime, and I'm going to cross off all multiples of 3 greater than 3, or at least the ones that haven't already been crossed off. The number 5 is prime, and all of the multiples of it greater than 5 are not prime. Circle 7 and cross off all multiples of 7. Anytime I hit a number that hasn't been crossed off yet, I know that it's prime, because if it had any factors besides 1 in itself, it would have been crossed off already. So at this point, since I've already gotten to the square root of my biggest number on my table, I know that I can circle all the rest of the numbers. They'll all be prime. The integers a and b are called relatively prime if they have no common positive factors besides 1. So for example, 21 and 10 are relatively prime, even though neither of them are themselves prime. But for example, 21 and 35 are not relatively prime because they have a common factor of 7. A set of numbers is called pairwise relatively prime if each pair of numbers from the set is relatively prime. So the numbers 14, 33, and 10 are not relatively prime because 14 and 100 are not relatively prime. 2 divides both of them. But the numbers 34, 15, and 77 are pairwise relatively prime because each pair of those numbers is relatively prime. This video defined prime numbers and relatively prime numbers and gave some simple ways to see if small numbers are prime.